Alright, we are doing some calculus here at Go-To Math, and we're looking at continuity and one-sided limits. And so we're going to take a look at this limit here. We got the limit as x approaches 10 coming in from the left-hand side of the absolute value of x minus 10 over x minus 10. So let's use that color there. The limit as x approaches, was that again 10? Yeah. Those coming in from the left. Alright, what I'm going to do here is I'm going to actually just let's draw a picture to this one. So when we plug in 10 into this, we get 0 over 0. So that's actually a problem, to say the least. But I'm going to graph this out. Now, the graph, you should know what the graph of this looks like. We'll call it g of x. So when I plug in, for example, 6 up here and 6 down here, what do we get? We get the absolute value of 6 is 1, or the absolute value of 6 is 6, and 6 over 6 is 1. So for all the numbers we plug into this thing, we're going to get the same number out, except it might be negative. But in this particular case, it's positive. For example, if I plugged in a negative 1 up here, I get a positive 1 out because it's the absolute value. But if I plug a negative 1 in down here, we get a negative 1. So 1 over negative 1 is just negative 1. Well, what's happening here is, for example, this particular graph, we can't plug 0 in because you end up getting 0 over 0. So that's the reason I got two open circles here, as you can see. But because this is x minus 10, what's happening is this graph is being shifted to the right 10 units. So we're going to say this is 10 right here, and of course this is going to end up, now this is not to scale, this graph is not to scale, okay? It is definitely not to scale, because we know that this right here is going to be a 1. Alright, so let's look at this. If I plug 10 in, obviously we get 0 over 0, so this is where it's undefined. But if I plug 11 in, right, we get 1 and 1 in the bottom. 1 over 1 is 1. So for every single value I plug into the right of 10, we're going to get 1 out. But if I plug a value less than 10 in, for example, we plug a 9 in here, we get negative 1 in the bottom. We get negative 1 here, but we take the absolute value, becomes a positive 1, so we have 1 over negative 1, which is just a negative 1. So as you can see, this down here is going to be negative 1. So this is what our graph looks like. It's basically two horizontal lines. But we're coming in from the left-hand side, okay, because that's what this negative states here, that we're coming in from the left-hand side. So as you can see, as we get closer and closer to 10 from the left, our y value is still staying the same. It's staying at negative 1. Now I'm going to add something else to this. At 10, the graph is not continuous, right? This graph is obviously not continuous because first off, the limit doesn't exist as x approaches 10. That must be true. At least that must be true. It also fails at f of 10, right? That must exist also if this is our function here, f of x, right? But this is our left-handed limit, and it is negative 1. Now let's go back and see, yeah, negative 1. I'm not sure what I've got here under the help. A bunch of stuff. I got all kinds of stuff going on here. So we've defined, we define it, and then, and there you go. All right.